Hello, good afternoon. Did everybody get lunch? Did you get your coffee? Okay. Simon specifically asked me not to talk too much. Okay, so I'm just kidding. Apparently, I talk too much. So this is a true treat for me. I hope for you as well. I'm a huge fan of event modeling. I came to know about it about 4 or 5 years ago, and I truly believe in the power of it and what it can accomplish. So this is going to be great. So I'm really looking forward to it. Simon Samarovski and Christian Tiel are from one of our partners, Holisticon, which is located in my favorite German city of Hamburg. Love Hamburg. So I hope you enjoy the conversation and the presentation. We will have a QA session at the end. So if you do have questions during the talk, it's up to you guys if you want to take those questions. But if you prefer to wait until the end, you're okay to tell them, just wait until the end. So yeah. Anyways, enjoy. And yeah, please help me welcome them.
Hello guys, I live the talks directly after the lunch, so everyone is like satisfied, and so take a seat. I'm thrilled to introduce you event modeling notation today. We'll see in a minute what it is. My name is Simon, and this is Christian, and we both work for Holisticon. And we also have a special guest here. He's on the slide. He's not here, but he's on the slide, and he contributed a lot to this development that you will see today. And yeah, so I will pass over to Christian. Actually, I think he will talk a little bit more.
Yeah. So what are we going to? Oh no. First of all, we are from Holisticon. Holisticon is a small consultancy company, tech consultancy company from beloved city of Hamburg, and we are not just tech consultants, but we also are consultants for the whole process of software development. So we want to sit on the table at the very beginning and accompany every of our customers through the whole process of designing and modeling the software up to the running software. And this is also why we are also a very big fan of event modeling. So what are we going to talk to you about today? So first of all, we want to talk to you about the challenge, the problem we wanted to solve with this so-called EMN. Then we are going to tell you, reveal the secret, what is EMN? And then we show you some tooling, some code generation stuff we have programmed, and finish with an outlook and a roadmap. And hopefully afterwards we still have some time for questions. So first of all, our problem or the challenge we want to solve. Quick question to the room: who knows event modeling or who does not know anything about event modeling? The latter one, who has never heard of event modeling ever? Okay.
We have two guys. Yes.
Two persons.
Yes.
Yeah. Unfortunately, this talk is not about event modeling, but I give a very short introduction. So, event modeling, it's introduced by Adam Dimitruk in 2018, and it's a collaborative method to design system. And in contrast to other methods, it's not focused on static data structures, so not like, for example, DDD, focusing on the structures. It's focused on the flow of messages over time. So where does information come from? How does information evolve? What do the user want to do with this information? And it provides a visual timeline of events that really have a flow of a user journey throughout the whole process. And therefore, it tries to create a shared language between business and the implementing tech guys. And for this event modeling, we today already have some tools. So originally designed, it was to be used with simply with sticky notes. So 3 different colors of sticky notes are enough to do event modeling. And out of this, especially when with digitalization. Miro was basically the tool to do event modeling with. Sometimes I've also seen Draw.io being used. And around this tool set, other tools evolved. For example, I think the most advanced one is the event modeling toolkit from Martin Dilger from Niebold, who's sitting back there and is having his workshop directly after us here in the same room. And but it's fascinating that I think in the last months or over the summer, every 2 to 3 weeks in LinkedIn, another tool popped up. So it's really interesting how many tools are at the moment evolving and how much drive this whole topic has. But most of the tools have a problem, and this problem is that they treat event modeling more as an image. So I have a workshop, I have a meeting, I can draw in a diagram, I can have some sticky notes with arrows between, and afterwards this image is somewhere saved and the programmer maybe starts programming. But it is not really machine readable. There's no validation, no automation. Every tool has its completely different format to store data. And when I want to use this now in real professional software development, I can't do it because I can't really read the diagram. And in contrast to that, in other projects, we have used a lot the specification of BPMN. This is Business Project Modeling Notation. And this is a specification from the OMG to streamline business process diagrams, basically. So here we see a very small one. And this is a real specification. And this specification is it's more than just a data format, especially when with the 2.0 version. It actually also integrated the semantics of what I want to do. So not just boxes and arrows, but what is actually meant with the diagram. And it became an industry standard. So it's an ISO standard, and it can't become more than an ISO standard. And what for us is it's so fascinating. So with some extensions, you can actually execute the diagram. So for example, with process engines like a Camunda modeler, you can take this diagram and you can execute it. And the business persons can see what is being executed in the software. And you have a real connection between the diagram, the model, and the code. And there I ask myself, Simon, wouldn't it be awesome when we have something for event modeling too?
Maybe. I'm not sure. Let's think on that a little bit. So what would be our goals? We would like to streamline the event modeling as kind of as official specification. So we say there is a standard and we know what we mean by that. So if you draw this box, underneath there is a model that says this box is of type event, and that means something for the system design later on, and we can deduce something for it. So we should define rules for the elements, for the relations, for the patterns, and we should also define visual rules for visual representation. So, I mean, we know it from the method. Adam invented it like this, saying that an event has a particular color. So we should enforce this as a part of a specification. And in a long term, we would like that this event model that we construct during workshops, that will actually resist as part of our system design, system documentation. So we can maybe validate this if the system still behaves correctly, that we can generate code out of this, but we need this interchangeable format for doing this. So without this, we only are kind of vendor locked into specific tools, and we lose some traction if we change tools. So some of the tools are focusing on the prototyping, and they're very, very strong in building this part. Some other tools, as you've seen in the presentation, probably on the main stage, they are not using the visualization right now, but why should I write a story like a story? Why can't I just import a standardized diagram that I designed in my workshop to this fancy tool in Axoniq platform, right? Why not? So we need something for that. And so what we are trying to do is we are kind of following the path of OMG. So what they did with BPMN was exactly the same thing. So they first had the notation, and then they understood that there must be the semantical part. So what we would like to propose is a language specification for semantics and the visual aspects of event modeling. Some of the people will be scared because it's XML-based syntax, right? So something from the 90s, right? In fact, XML is very interesting. I mean, if you're not typing it on your own in the editor, it's very fancy in terms of it being extensible and validatable by automated tools. So you get it for free from this standard. Of course, we shouldn't ever look on this XML as humans. But for the machine, it could be really advantage because it's very easy to parse and very easy to process. And we should apply the same ideas that OMG did for other specifications. So this clear separation of the semantical part, saying what are these timelines, specifications, slices, all kind of types, commands, events, whatever. So how this relates together. And on the same part, we should follow, and this is how BPMN also is constructed, having the visual part, which says, okay, I have some diagrams and shapes, and these should be displayed, and this should basically reflect my semantical model. So we started this journey. So I will give you some diagrams showing where we are currently now. So we basically, so in this diagram, you see the green, the dark green elements. These are the elements that you really see and use in your model. Like you see this timeline. So we were always speaking about journeys, forming a timeline. Maybe we should rename it to journey. So this is an open discussion. So the main thing that is missing in this one is actually hidden behind these flow elements on the right side. So we know that basically we are constructing a graph of flow elements and connection between them, right? So for that, I just extracted a part of this semantical model that basically we have the flow element being flow node, which is a box in the end in the diagram, and the message flow, which is a connection between two boxes, right? And then we have all of the common types which are used in event modeling, like event, command, view, and all these guys there. In the same time, we observed an interesting thing. If we draw a diagram, we actually, and put a box on it, or a sticky note, we actually mean two things. It's an instance of, let's say, command, but in the same time, we're defining a type of it. And sometimes we are switching this perspective. So sometimes we notate values on that, saying, okay, it says this particular create student with that name. So that's an instance. But I have the name attribute is actually attributes of the types, right? So I have two informations hidden there. And because, I mean, of course, if I put and stick it there, I don't want to first create a type and then, create an instance. This is boring, right? So the method should lead us through that. But underneath, we need both representations. So we need the structural information about the types and the instance information. So let me get a little bit more details on this. These types and instances. So the types are kind of reusable structure. So we know it from programming. If we're writing classes, right, these are types, right? And instances exist then in runtime and have particular values. So for the type, I need a way to be able to specify a schema, like a format, what it is. And it can be, of course, interchangeable. And we decided that, schema definition language is not what we want to invent again and put into the specification, but we will just say, okay, probably you will use your specification language of your choice. You can use XML schema, you can choose Apache Avro, JSON schema, whatever you like, right? Or comma-separated text of your company if you like this to describe data structures. So this doesn't matter for the standard, right? For the instances, we want to provide values. Again, we don't want to enforce you in what format you're providing values. Here are some examples. So taking the snippets, I promise not to show XML, but I will do, I'm sorry. So here in the top, you see the type definition of basically an event. And it references to some external schema with a namespace and a name. We don't know how this is resolved, but this is not part of the spec. And we see in the value that there is some ID and name given, right? So it could be that easy. And in the end, I promised you that there should be UI semantics, so how we draw it. So, and here we fully align to what OMG is doing, actually. I mean, they designed several languages. One of them, if you don't know BPMN, you probably have heard about UML. So it has the same problem, expressing semantics, expressing diagrams. So they have a dedicated specification called diagram definition. And this consists of two parts: diagram interchange, which is focusing exactly on this building a spec that is interchangeable between tools, and diagram context, which gives you a little bit more. I mean, you want to draw something, so there must be coordinates of points and whatever for the diagram, right? So this is a flavor of applied specification, and this focuses on this EMN stuff.
Yeah, but all this XML stuff, isn't it a little bit boring?
Well, I like it.
Yeah, so
Yeah.
let's show something more fancy, I would say. So let's show some tooling around EMN. And yeah, in the introduction I said that there are a lot of visualization tools around EMN already evolving. So we had an awesome and amazing idea. Let's build another one. Ours is, of course, the most best one and the most advanced one you will ever see, so forget all the others. No, I'm basically just kidding. I think especially the one from Martin is quite advanced. But we have designed a language, and we somehow needed to use that language or create documents based on that language. So we created EMN.js, which is an event modeling tool. And it's based very much on what the BPMN guys did with their specification. So they have created something called diagram.js. This is a great, awesome toolkit for creating basic diagrams in JavaScript. And they added on top of that the BPMN.js library for the BPMN diagrams. And we more or less did, now the very same, and build our own tool on top of their library to design event modeling diagrams. And no, that way. And so we don't have that one. Okay.
I think you have to press escape here, maybe.
Does anyone know how computers work?
Yes. If you have questions, ask me again.
So this is our EMN modeler. And in this EMN modeler, I, for example, can open an example here. We can see, or some can see on this small screen, that we basically have this kind of timeline structure. So we have one timeline, we have multiple lanes, the flow elements like a command to create a student course. So this is, for example, the factual example Axoniq is always using, to connect it to an event created, leading to a query and so on. And also implementing slices that we can group everything together, and also that these slices can be connected to specifications. And these specifications are a very nice thing, because with these specifications we describe not just the timeline itself, so what may happen inside of a user journey, but also what will happen in a very, very particular case where I have a very particular command with specific values. And I can also, like Simon described, I have a type system, so I can really reuse the same shapes, the same types again. I can give them values, and I can even use common patterns of event modeling. So when I, for example, start with an empty one, in event modeling we have these four basic patterns. The pattern of I want to do something, that's a command slide, I directly can place, and I can then edit and give them new names and stuff like this. When I want to see what's happened, I have the view slice upwards again, and also when other patterns like automation slice, something happens, so I want to have something else happened again. Or translation, something happens somewhere else and I want to have it in my system. And for us, we think it's a quite nice tool to quickly model something. And in the end, we have this. Okay, I show it again. It's an XML, and here it looks even more ugly because it's a quite big diagram. But like Simon said, it's a really big diagram. No one should ever have a look on it on his own, but always use kind of tools for it. So when we are using BPMN, we do the same. We never look at this diagram. It's ugly. Of course, one thing we have to mention here, everyone is talking about AI. Of course, we have an AI assistant. So we can also, when I, for example, start with an empty timeline, I have a prompt then maybe he's thinking about something. So you have Wi-Fi, yeah. And at some point later, in maybe a few minutes, or we get a drink in between, and I don't know what I have to talk about in the moment, it actually generates stuff and tells me afterward what he has generated. So this AI generation stuff is, in the moment, it's just to mention it. So actually, it's in the early stages. And also, I don't know, AI. Do we really believe in AI? Do we have something cooler we can do?
Yeah, so I told you that I want the specification that is machine readable, right? So not sure why, but so we would like to do some code generation, right, out of it, because now it's machine readable. Now we have the standards, so we can try something. So do we believe in AI code generation? The short answer is no, we don't, because I want to the code generation to follow my strict rules. And these strict rules are usually set up by my environment, by my company, by my customer, whatever. By no means there should be no exception from these rules. And if there are exceptions, I would like to see these exceptions and notate them as there is exactly one exception from my rule. So it should validate provided input. It doesn't tune the input that I provided with my customer workshop, because the AI wants to do so. It should enforce assumptions that actually I have to this model. The whole idea of event modeling that I don't over-specify. So I'm doing a workshop with the customer, and then I enrich it with required data. So when is it good enough actually to generate code? I mean, can AI answer this question, or will it just invent missing pieces? I'm curious about that. And in the end, I want 100% reproducible, repeatable code without any exceptions, right? So this is the input, this is the output. So I don't want any reasoning to happen between. So again, putting human in the loop means for us, we can do a lot of AI during the modeling phase, and we can use AI to support us. But once we set the model, we are ready. We don't need any artificial intelligence to say what the system should look like, right? So this is kind of, I don't want to do that. So as few of you probably have been here last time, we were speaking about code generation, Kotlin code generation, so we did it again. I'm sorry, we do it every time now. So what we built currently is, so it's a very early stage. It's a pluggable infrastructure for custom code generation in Kotlin. So we have actually the infrastructure, and we provided one generator cartridge. This is, term from model-driven software development back in the 90s. So you want to use it, you want maybe to use your own, to build your own. So we are focusing on providing actually an infrastructure that people can generate stuff out of EMN, right? And it will be packaged as Apache Maven plugin. Later on, maybe Gradle, if Jan has time, he will support Gradle too. So our opinionated choice for now was going for Spring Boot and Kotlin and Apache Avro serialization, and we follow this vertical slice approach, which is questionable if it fits to your domain. So we built something, and yeah, let me show you what we've built actually. So as I promised you, there is excuse me. Not
XML
only,
again.
Yeah, XML again. I'm again back with XML, so hopefully it's okay. So you see there is a 0.0.1 snapshot version of the plugin available, which is already public on Sonatype, so you can download and use it. And I configure it basically to generate stuff out of it. So I have the model, and we can actually, so we have a simplified model now for these. So what we're gonna look at is again from this faculty domain. So we have currently here create course. We are only focusing now on command handling because event handling just got to the preview release 4 days ago of the framework. And we would like to generate Axon 5 framework code. So it was very, very, very sharp edge. Then the other one, there is a student enrollment going on, and then we can also rename courses, which is covered. And underneath, we have the specifications. In the specification, you see there are some values provided here. So I basically have here some values, and then say if I create course with this capacity and this name, then the event should contain the same capacity and the same name, right? So this kind of trivial given when then scenario description, we know it from Gherkin or behavior-driven development in general or whatever. We can also specify this error cases. So this is exactly what the guys in the previous room were showing. So this is exactly that in event modeling. So there are parallels, right? I told you about the type systems, right? So every time we see, probably it's not visible on the screen, on the right corner there is a small sign, and this means we have a schema provided to that. So here underneath there is, currently we only support this Avro reference because we built the Avro support in Axon Framework, so we are big fans of that. And this one is actually a namespace and a type name. So this is what will be in our example. So if you look here inside, so we have the EMN, and nearby there is a Avro type definition, and all the type names that are referenced from there are currently located here inside. So here you see there is a rename course command with a course ID and a name and whatever, right? So structural definition of what is actually being designed. I know we can speak of if it's a good idea to take a visual editor and give you a possibility. Okay, if I'm boring now, I could say to chat with an assistant to add me a name there. But okay, I'm not boring. We could do it visually, but I still believe that if you are on a professional software development level, you're much faster writing specification in JSON or in XML schema or in Avro than, you know, clicking in a UI tool and saying, add me a property of type string and whatever. But this is, again, arguable. So, and as I told you, so we will just run these codes. So currently there is nothing here, and what I will do is just call maven clean install on this project. There is one particular thing which is interesting. So in the configuration of it, we say generate concrete state implementation, set to true. And now let's look. So this build just succeeded. So let's see what it had generated for us. So we have a generated sources here, and we just open it up. So don't be afraid, that's Kotlin. So all the types that we defined go to this currently one single file, and we defined actually events, commands, so they're all in here, right? So basically we took the Avro specification, generated the entire code base from it. And if you look carefully, you will see here the event tag, for example. This is something that Axon 5 introduces, saying this is exactly the interesting tag value. So if someone wants to fire this event, then the tag name that the event is tagged with is actually located in this field. So that's the tag will be course, and the value will be the value of the course ID, right? So this is exactly the DCB stuff that Steven was speaking about, and how the Axon Framework 5 will use it. So in addition to that, we discovered actually 3 command slices: create course, enroll student, and rename course. And if I open it up, you'll see basically 2 classes generated. So here we have a command handler, which is a regular Spring component and a command handler. We inject here the create course state. So we go for the idea of having state per slice. Again, your decision. At this stage, this is the only thing that we support, but I know we are experimenting with that, right? So, and maybe you will write a different one. So passing in the event appender, and we follow the ideas of Ivan, of F model, saying actually it should be the state you should focus on. So handle is only plumbing stuff. So this is what we got generated, right? We get a state, it is event sourced, it has a tag, it has an ID type, it has a very natural constructor, which is an entity creator, and we have a decide and evolve function, right? So the decide one is, if my state receives a command, do I want to accept this command or reject this command, right? This is the decide pattern. And the evolve one is actually what should happen if the event is received here. Which is, by the way, interesting that event handler annotation is not present there. Yeah, I think it should be. But that's another issue. So usually, it was, yes. It was on your machine, yeah. So let's see, you remember these specifications. We have these specifications, so what can we do out of that? Now that's easy. Of course, this specification is a one-to-one mapping of what the Axoniq fixture testing is doing. So we can just take it like it is and just write our tests, right? Directly from the specification. And this is exactly the point where I don't want the EI to be in between this test and testing the production code, because sometimes EI just deletes tests, modifies tests in order to get them green, and this is exactly what I don't want to have, right? So if I would now run this test, what will happen? Any expectations? I mean, I have a generated state, so I never made any decisions how it should be implemented. Of course, this will fail, right? And this leads us to a very comfortable position. So we're generating code, we're generating tests from our specification, and the tests say, hey, implement this. Perfectly fine, right? I mean, we are there. We created a lot of stuff from our specification. So instead of implementing the state now and moving it on, I would just check out another branch. And where the state is already implemented, I should have done that. I forgot to do that, but now it's there. So what is the difference now? Now the state is implemented. So let's look a little bit more. I should have done it in before. Yeah, but now it will eventually do it correctly and import this stuff that I want to import. This is just idea. It's now it got it. Because we were deleting directories. So now we have a state that actually is implemented. So now we have the rename course, and now we decide if course doesn't exist, or if we rename to the same name, then don't fire any events. In this case, event source and handling are there. So we are fine. So if I now run the tests, so never touch the generated tests. They are still in the generated test folder. Let's take this, just run it. So this should be green. So wonderful, we completed the task. We have our first command handlers with a lot of stuff generated out of our model directly. And it's boring just to look at the tests, right? So in the background, I have an Axon server dashboard, which currently has nothing. It's empty. It has a context. It's a DCB context, and it's empty. So now let's probably start this application and look what happens. So Spring Boot start. Wow, it's already done. That's fast. So what I wrote is a small command line runner that actually does a create a course and then rename a course. So we see the command side and the read side is working. And if we go now here and query again, we see, hey, we created events and they are stored in Axon server. So probably we are able to generate a lot of parts of our system just from decent specification, if we do so. And this is my answer if we like code generation with AI.
We don't.
Oh, no, we don't.
How?
Yeah.
It depends. Yes, so on the last few words, some outlook and roadmap. So as a summary, what have we seen in this talk? We've seen three things. We have shown you our event modeling notation as a new proposed language for everything we will ever do again with event modeling, hopefully. We have introduced a first probable editor to use this event modeling to create the diagrams. And we have also proven what we can do with these diagrams. So we have shown here now we can generate almost a whole application with it. We could also imagine that at some point we can just verify some things in an existing code or so. But yeah, we actually can do something with this code. And yeah, this EMN, funny thing, is even funded by our German Ministry of Science because they think also that this is an awesome idea. But this, of course, is just the beginning. So now, so this is our EMN 0.0.1 minus snapshot version. So this is now the time where we want to have the opinion of all of you about yeah, this language specification. So is it enough? Is it correct? Is it wrong? Do we use the correct namings? Are there some things missing? And also this EMN.js modeler is just one example modeler. We had to use it, we had to program it to use the language, but of course there are so many others. And what we like to see is that EMN is adapted in your event modeling tool when you have one. If not, create one. And so that this EMN gets even more widespread over our whole community. So the QR code, I've seen a few of you have already scanned it. So it leads to a specification. Escape. Escape. Yeah.
No.
Oh,
No.
it worked.
No.
Somehow.
Didn't. First. It
Yeah.
worked here,
Computers. So we already published a language specification with also with everything described what we already have. So with all the diagrams at some point also with XML. So this is already public, but as I said, it's debatable. So we want to be debated about it. And
we introduced some errors, and we are finding out if you will read carefully and point them out. That's a test.
Yes, and so on the short term, we want to add more stuff to it. So kind of DCB state specifications. We want to publish and release all our 3 artifacts for the first preview version that everyone can use it. And yeah, basically, as we said, on the long term, we want to make EMN, or this is our big final vision in the end, that EMN gets the lingua franca for event-driven requirements like BPMN is for process modeling in general. And I think these are some bold words for the end. And in the end, yeah, thank you for the audience. And do you have questions?
Yes. Do I have to switch it on? I'm not sure. No, try to. There is a small button here. Try again.
Hello. Hello.
Hello. No technical.
Just wanted to say thanks because I've been using some other tooling and I was really wanting to just create like a schema or something like that. So this is fantastic. So first of all, I just wanted to say XML. Can we do better? Like YAML or something like that, maybe. Like you've got the Open API spec, you've got the async API spec. They've got models in, things like that. I wondered if is there scope to change that? Or
I think one of the important things there is so what we were looking at that from kind of perspective of how you want to deal with that. And the point is, so there will be more or less definitely, it doesn't matter what standard you take, it's a tree-based language. XML is one, JSON is one, YAML is one, right? So you always have a tree. The second question is, how extensible is it? It's a very interesting issue. So JSON and YAML allows you to be extendable to be like any attribute extendable. So probably it's very easy to create languages that are then that extendable that you cannot validate them anymore because you cannot prove it anymore. XML does better at it, exactly on this validation stuff. So you can say, okay, I can insert some additional elements which are just ignored, and this is one of the things that you need for an interchangeable language format. That basically, if you don't understand the element, you just ignore it, and you preserve the structure. So that you are parsing your part, and an additional thing that you have in XML is XML schema. So basically, it gives you a very easy way to say, my tool inject these certain parts, and I specify it with a schema, so I identify them on my own. I don't have name clashing with any other, globally. If someone says value, is it that value from that domain or that domain? So XML really on the language level does better than JSON does. And again, a human should never write it. So I had to write, because before we had an editor, someone should start writing that. That's why XML. So validation and extensibility.
Any more questions?
Here's one.
In the Axoniq platform, I saw the not a visual but a language output with highlighted events and commands. Will it be a nice addition or a possible output from this language as well?
Why not? Of course.
Yeah.
I mean, the point is, so we just said that at least for the moment, we see no value in providing a language for type specification or a language for value specification. We should use something that exists, right? So there is JSON schema. If you like to do this, go for it, right? And so starting from this, if you have a JSON schema, then map it to something that you basically see there. Why not? Another question is basically what you've seen on the Axoniq platform is that there are several specifications you have seen there. So once you've written this story, then first of all, you get something which is user stories kind of very similar to event modeling notation. So it could be just an export button, right? To open it with your own tool and model further, for example. And then do the roundback, so model in your own tool and import it because you already had the session with the customer or, working asynchronously. So this is one part. Then the schema information is the second part. So what is inside of the messages. And I think the third part, which we've also seen arguable, I mean, in the end, you had the component diagram. It was not a diagram, but you were deciding on components, right? So there should be also an interchangeable format for that. And again, if we are not speaking about greenfield, but brownfield, then you should somehow connect your code or your existing code to this. So you should be able to maybe scan your event classes and deduct schema out of it and then reuse it for a new system construction. But this is, so we look on this from very non-romantic machine-readable perspective to say everything which is actually not processable is just not there. We just lose this information. But I think there are ways of doing this.
Great work. Thank you.
Yeah, thanks for this talk. I have a question regarding the tests. As far as I understand, they are always regenerated every time I change the specification or the model. The tests are overwritten, and then I test my application against the new specification using these tests, right?
Currently, yes.
Yes. And how about the implementation? Because I assume you only can generate it once because there's some custom code the user has to, or the developer has to add, and then I don't want to overwrite this code.
Yes, I forgot the escape button again. I'm sorry. So now I will learn it. maybe eventually. Okay, so
year.
the point is, thank you, great question. So you're addressing two things. So one of the things is, so our packaging was Maven, and of course it's up to, and we can make it much more smarter, and it was just a matter of time that we didn't actually. So currently we are regenerating and overriding it, and this is the reason why we generate it into generated test sources and generated sources, right? So it's not in your main source base. And the same we do for the rest of the generation. So we were experimenting around with AI. I'm sorry. So in IntelliJ you have this Juni, and the Juni you can tell, could you, by the way, I have some red tests here, could you please implement this state, and after the tests are passing, move these from the generated part to the source part? It sometimes worked. Jan says it works always, that's good. I'm scared of this, right? So there should be human checking actually. And I mean, in the end, we are speaking about, you know, system behavior, and we say what happens if a command is arrived, and we are writing external specification like BDD style. Yeah, we should think about the command model, right? So why not doing this? And maybe we can get assisted support there. So again, it's a question of life cycle. So I can integrate it into a continuous build and override it all the time. For the generation of the code type, which is actually here now in generated sources, there is a pattern from back 90s called generation gap pattern, which actually means that the part that is generated is somehow extended by a component that is handwritten, which is a known pattern. We try to implement this currently. What Axon Framework is doing with the polymorphic state implementation is not really allowing to do this, but we are in discussion. So currently you need to, on the state, so on the class that is actually what you're injecting, you have to specify the concrete polymorphic type. So you have to know the type in advance, which breaks the generation gap pattern. If we can reverse this, or maybe provide a supplier for the subtypes, then it's solvable, and then you will basically you will generate the stub, and you will implement this stub in your code, so you will not regenerate. So, yeah, or abstract classes or whatever. So the idea is, and this is I think the idea where we extremely align with Ivan, is that if you're building your domain model, there shouldn't be, you know, annotations coming from a vendor, right? So I mean, we have a decide and evolve. It could be functional. It should be purely domain code, not plumbing. And we just showed that we can move this plumbing actually to the generated part, and that you as developer focus on the domain part, right? So that's a goal. Okay, we are out of time. I'm sorry, we stole 4 minutes.